you're going to go right down to 0. Boom, the thing launches, right?
Yeah.
And then you'll take it. Then the engines will cut after 8.5 minutes, and either you're in orbit or today. I mean, on the real day, you'll probably be in orbit after those 8.5 minutes.
Gosh, yes.
And then, but what will happen today is probably not that on all the runs, right?
Probably not. You know, there's probably a good spread. You know, I'd say we'd practice a transatlantic abort landing. We'll practice probably an RTLS, return to launch site. We'll practice an abort to orbit. There's a whole bunch of different flavors. You know, Ascent, you got all these different, you know, tangents that you can take. It's just all these different options, and you got to, you know, pick the best option. Sometimes the best option isn't fun, but it's the safest option at the time.
Right.
So,
what do you get out of these sims? I mean, because obviously, you may. It might be that you're going to get you might have to do one of these aborts for real, but you're getting more than that, and it's not just practicing the abort, right? What do you look to get out of your team today as the flight director? What are you looking to try to accomplish?
You know, I've been working with a lot of these guys for years now, so they know me, I know them.
Do you have any ritual you'll do on that day?
No.
Is there anything you have something for breakfast, or
you know what?
you're gonna
I do
wear a certain tie or anything?
The tie, I'll figure that out. I might have a nice tie. You never know.
It was a nice one today.
Oh,
actually.
thank you very much.
Very nice.
I appreciate that.
Yeah.
But what I'll do is, it's just, you know, the drive in, just kind of get my thoughts together. That's kind of when I put stuff together. And I always have
You listen to Metallica or something like that on the way in?
Sometimes. You
really?
know, it just depends. Yeah, sometimes. It just depends on the morning. But usually I have a Diet Coke or something. I've got to get the Diet Coke. So, you know, that's about the biggest ritual, but that's every day.
How you doing?
Good to see you, man.
Jim, how you doing?
So where's your tie?
I only wear it on special occasions since I don't usually dress up much.
Yeah.
You got to save it just for the right time. Otherwise, it's not special.
You know, that's a good point.
Yeah. So Richard, he looks the same way every day.
You don't wear your game jersey when you're practicing in the mud.
That's right.
He's got a good point there.
I get dirty. I roll my sleeves up. I get ready to swim.
That's right.
I get ready to go.
That's right. All right. Well, we don't want to distract you. What are you doing? You're gonna sign in and stuff?
Yeah, just getting everything set.
All right.
So we are getting ready for the Ascent sim this morning, our fourth one with the 133 crew.
All right. And what are you guys going to be doing during this sim? Your ground control. Here's the thing, right? It says ground control.
Ground controllers are responsible for the building itself, making sure that everything's operating so that the rest of the team can get telemetry into the building. We can get commands up to the orbiter. Also coordinating with the network, in this case a simulated network that's generated by a model over in Building 5 where the other simulators are. And our job is to make sure we have telemetry, command, and voice capability with the orbiter. And whenever that breaks, which we're expecting to happen several times this morning, then we've got to work with the team to restore it as quickly as possible.
All right, and it's same thing during the flight,
Same
on
thing
launch day.
during the flight.
Tell us your name, what are you doing?
I am Mark Mcdonald. My name is Mark Mcdonald. Ascent Fido. This is our trajectory officer. Your name, Gruber.
Did you go to Boston? You went to Boston University?
I did.
That's pretty cool, because most people go to Texas A&M around here.
There's a lot of those, yeah.
Yeah.
And I went to Colorado.
You went to Colorado? Where'd you
Along with our guidance officer.
Really? You went to Colorado too? This is
It's the Buff Trench.
So this is like the
I grew up in Nebraska. No.
We
I
are.
don't even know what he talked about. The Buff Trench. Was
Yeah,
that?
it's Buffalo.
Oh, I see. But you grew up in the.
Nebraska-Colorado rivalry.
Is there?
Football.
See, I'm from New York. I have no idea. We just have fights between families. All right. So what do we got? What do we got going here? What are you doing right now? What's going to be your job this morning?
What we typically do, both pre-launch and pre-simulation, is we get the targets, guidance targets, ready for launch based on the station state vector.
Okay.
So, and that's called the IWIS. So that's where the shuttle's going to steer to.
Okay. So by target, you mean like where you want to put the space shuttle so that it can
Correct.
hit the space station.
Correct. So we're setting it up to rendezvous on flight day 3.
Okay, but you already know that, right? I mean, you figured this out for years, right? I mean, for a long time. I mean, you know where the station's going to be.
Right.
But it might be a little bit. It might be different today, or is it going to be different than what you?
Its altitude will vary flight to flight, and our topo officers keep track of that very closely. They have to.
Topo, what does that stand for? That's.
Trajectory Operations Officer.
Thank you.
Thank you. I'm
Trajectory
glad you're
Operations
here.
Officer. That's the trajectory person on the station side.
I'm the FIDO lackey, basically. I provide things like that and coffee and.
And of course, they're having to maintain a trajectory in coordination with the Russians and other partners to make sure that all of the visiting vehicles are going to be able to rendezvous given their performance capabilities.
In relation to the, what's that?
What-
Is that your mom?
That's a ring bell.
Hey, telling us to go
Mom,
away?
I'm right in the middle of something.
All right, tell me you're busy. Who is it? All right, so you really
So
you
that's
need
how
to
our-
pick that up? Who is that?
No, I don't need to
You
pick that
sure?
up. The
Maybe
topo,
it's-
our
maybe
trajectory
it's the guy
operations
telling you the
officer is going to
space
pick that up.
station's in the wrong orbit. All right, so we've got Bryan Lunney here. You're a flight
morning.
director.
Yes,
Good
sir.
morning, Bryan. Thanks for that. I know you're very busy, but we appreciate you taking a break.
Glad to be here.
And you're a flight director. You've done shuttle station. You're also Ascent. Is that right?
Yes.
Okay. And if you can tell us what's going on back here.
So for each front room person, there's usually a couple of back room people helping them out. The back room position usually is a smaller piece of the front room position so that that individual can come in from college or whatever, a newer guy, and learn that smaller piece, learn the other smaller piece, then move out to the front room. Right here we have the flight
the
dynamics.
front room being that room.
Yes, sir, out in the
All right,
mission
all right,
control.
All right.
In the back rooms, we have the flight dynamics MIPSR, multi-purpose support room we call them.
Okay.
And these folks are supporting the flight dynamics and the guidance and procedures officer. Here we have our navigation folks helping us figuring out where we're at, which is an important function, we think, right? So these guys help us determine where we're at so that we know where we need to go.
That's good.
Here we have dynamics folks. Good.
Okay, and they feed into who? Who do they?
FIDO, flight dynamics officer,
Okay.
and guidance, the two guys down front.
Okay, that's so all these folks back here feed into those
Yes, this
two
is-
positions in front.
Most disciplines, the systems disciplines, will have one or two guys in the back room.
Okay.
Flight dynamics has a whole lot more
Because
there's a whole lot more going on at those consoles and what they're supporting. And plus, it's only for ascent and entry that they do that.
but why is this so important during Ascent? Why is this? State
Because
the
it's
obvious.
so
for me.
dynamic.
Yeah.
You got your three main engines driving, you got your two big SRBs driving, and the vehicle's going hopefully in the right direction, of course.
Right.
And they're monitoring the performance to be sure that we hit our MECO targets at the right time. And if you don't hit your MECO targets, your velocity...
Main engine cutoff.
Sorry,
There you go.
main engine
All right.
cutoff targets, your velocity, your glide path angle, a couple other important parameters to make sure that you're going in the right direction in order to get to station. If you don't do that correctly, you may not even get to orbit.
Right, and what can they control? Because they can, when you're inside the shuttle and the thing goes, it's kind of like, well, this thing's on its way and we're going wherever we want. But they can actually adjust what's going on while we're sitting there taking our ride.
They will ask the pilot to adjust, for example, a throttle setting.
Okay.
Change how fast the throttle's engine throttle up from 104% down to 66%, for example,
Right.
or whatever they need to do.
Okay.
Sometimes we go to max throttles for certain main engine out cases and
Okay.
contingency abort cases.
All right.
One of the counterintuitive things they'll ask you to do is throttle back so you can burn longer for TAL targets, which always makes people
Transit,
confused.
going over the ocean if we can't
Yes.
make it there.
Yes, if we lose an engine early, we end up going over, aiming for a landing in Europe, they'll ask them to throttle back so that we can
Save
go
gas.
longer. Yeah, it
Sorta,
helps
kinda?
us. It helps the MECO targets,
All
again,
right.
the main engine cutoff targets.
Okay.
So on this side of the back room,
Yes. What do we got here?
you have the systems, one of the systems, back room personnel. And for example, right here we have the computer folks, the data processing system, supporting the DPS officer up front. We have the ENCO back room, who take care of the communications, instrumentation on board,
Okay.
making sure the S-band and the TDRS and the ground and talking to the Mila ground sites are working well. Over on the far end, you have the MAX, mechanical folks, taking care of all the mechanical devices on board, the vent doors, the landing gear, all those big things like that. And then the electrical folks are kind of in between there. Eagle, supporting Eagle, they take care of the electrical fuel cells and distribution of electricity throughout the vehicle. Then the life support guys and the thermal guys support the EECOM. They take care of course, life support, make sure the cabin air is good, and the thermal, make sure we're doing cooling on the vehicle. Of course, inside the vehicle, you generate a tremendous amount of heat from all the computers that are turned on. So
of
we got to
equipment.
have water loops and freon loops that pull that heat out of the vehicle and dump it out in the radiators. And also through the fence.
All right.
And then over here we have
Flap evaporator,
Yes. Keep
evaporator
using
system. All right.
acronyms.
Okay. Acronyms. Lots of acronyms.
Guidance, navigation, control. This is the back room that makes sure they can control the vehicle. And we got sensors and controls, takes both. So they're sort of the steering wheel, if you will, of the vehicle for a car. And then on the far side, you have the propulsion guys and the booster guys. The prop guys do the OHMS RCS, which are the small rocket engines you don't see during launch and but you do use during entry. To the left of them is the booster back room that does the main engines that are the big rocket engines we see at launch. So again, the same idea. Take one discipline, one systems guy out front, break his system up in a couple of small pieces, and then divvy it up here in the back room for someone to specialize in, so they can learn that discipline, and then train them to help you out during the flight.
Who made the cake? You make the cake?
I make the cakes.
What's your name?
Cathy Bupane.
Kathy?
Mm-hmm.
What's your last name?
Bupane.
Bupane. Okay. And you make every one of these cakes?
I do indeed.
You do?
I do.
So
Every mission.
This is the special launch cake?
Yeah.
Which is the carrot cake?
Yes.
And
We've only changed it a couple times, and they don't
Okay.
like it when we change it.
All right, so this is one of the reasons you have a simulation as well, is to make sure everybody likes the cake.
Yeah,
Is that right?
it's
Give you
kind
a
of a
little
sim.
practice?
Well, we haven't had a mission in quite a while, so I sim them every once in a while, and I've
Okay.
discovered I have a thermal issue with my oven, so it'll have to be fixed before we go to launch.
That's why we simulate. It's not just to make sure that we know what we're doing with the space shuttles, that you get the cake right.
That's right.
And you can make changes. You can adapt to the change. All right, so
So they can't fly without my cake.
all right, what else do you do here beside the cake, though? You must
I
have
used to
something.
be a TAO.
Which
I
what?
used
What
to
is
sit
that?
down, the trajectory applications officer.
Okay.
We manage the server that produces the trajectory during the flight. But now I work for FDOC, and so I.
That's that. That's
What does? Yeah, that's the new contract. So I do mostly sustaining work and contract paperwork.
okay. And the cakes.
And the cake. Well,
The
yeah.
cake's on
I
the
come to
side.
do support for missions, so I support the 3 primary phases. So
Okay. So it's the carrot cake for Ascent.
there's a coffee cake for rendezvous.
Yep.
And there's a chocolate cherry cake for landing.
Let's see, Fido and DC turn around for run number 3. All those being
All right, so how did it go?
Wow, that was probably the oddest RTLS I've ever seen. I don't know if you guys saw the trajectory up front, but
I don't think we got any film of it, but we can see a little bit of it here. Can you see it? What are we seeing here? That's just
that
the
part's
hack.
the nominal part.
Yeah.
But the crew had to take manual control to overcome an engine out that was not recognized, and gosh, it was a rough one, but successful.
But you made it back.
Yeah, from a sim perspective. Yes. Yes.
I am the Ascent Entry EECOM for 133,
Okay, which means what?
which means that I work launch and landing, and I take care of all
Very
the
good, that's
environmental
good.
control systems for the
Okay,
shuttle.
which is
The air they breathe, their temperature control,
Right.
the water they drink, all the
right.
good stuff.
all that stuff for,
Yeah.
for the crew. And what happened? You've had this is a simulation day, morning, but you can fit a few different runs of simulations in those 4 hours. So you've had
Right.
2 so far. How's it going so far?
So far it's been pretty good. We had
Yeah.
a cabin leak the first run that we were able to
the air
isolate.
was coming out of the cabin. All right, you're able to stop it.
Yeah, well,
That's
it
good.
turned out it was in the airlock, so thank goodness we were able to stop it.
Well, then you can't use the airlock, right? Okay.
Well, it depends on the leak size. If
All
you
right.
have enough consumables on board to be able to feed the leak, then sometimes you can reopen the
Okay.
airlock just to get certain things out and then close
Right.
it back up tight.
Okay, because you need that for the tunnel to get to the space station, don't you?
Exactly. If you dock, that could be an issue.
Okay, so you'd have, if this was a real problem, you'd be figuring out whether or not you could continue.
If we had enough gas on
Gas.
board to be able to feed
Right.
the leak,
Okay.
yeah, and get things out. And we have to go in there anyway and get out the suits because you don't want the EVA suits to
No.
get down to vacuum because that can decertify them. So we got to
Right.
go in there and pull those things out
Okay.
and then close it all back up.
All right. All right, but you found out where the leak was. Did you
Yeah.
end up stopping it then, or no?
Yeah, we stopped it. We closed out the airlock completely, made sure that we can completely isolate it. And then once
Okay.
we knew that we could close it out, then we reopened it, got the suits out, and closed it back up tight.
Okay, you did this after the launch, and you had them doing this stuff.
We had them doing all this,
All this
post-MECO.
Okay, so that's what you had the crew doing after the. So you had the leak all the way through the Ascent.
Well, we picked it up about 5 minutes into the
5
flight.
minutes you had it, but it was until the crew got out of their seats to close it.
Yeah,
that
there's some valves on the airlock
Oh,
hatches
yeah.
that they close, and that'll stop it.
Okay, good. All right, so that was the first run, you said.
Yep.
What happened on the second practice
The
run?
second run, we didn't have too much. It was an RTLS run, and so for us, it was just monitoring all the
Return
nominal.
to the launch site, come back around.
Yes.
Okay.
So we were monitoring all the normal stuff. We're going through all of our different cooling configurations that we use going uphill and then coming back
Right.
down. So we were on the FES going uphill, which is the flash evaporator
Thank
system,
you. Mm-hmm.
for a while, and then post-MECO, post-engine shutdown, then we go to ammonia, and we have ammonia cooling to the ground on an RTLS. So just monitoring all that
Okay.
nominal stuff, making sure everything goes okay.
Now you talked about breathing air for the crew and temperature for the crew, but it's temperature for this equipment too, right?
Oh,
Because
right.
that's really that generates a lot of heat.
Right.
I mean, we have a lot of hot air, but it's also the heat from the equipment.
From the
right?
vehicle, yeah. The first run, actually, we did have some problems with cooling. The flash evaporator shut down, so we had to go through and do some restarts on that and restore cooling. Because if you don't have cooling on the vehicle, you have to come home.
That's all good. You need to have the cooling.
It's very important.
Right. All right. So you handle the cooling. It's not just keeping the crew comfy, but keeping the space shuttle.
The entire
Keeping
vehicle.
The space shuttle comfy. And we saw some of the folks in your back room that are feeding you information, and you're working here with the flight director.
Right. I have
and
two
all that
great
stuff.
back rooms. I have a life support and a thermal.
And they feed you information so you can help make decisions based on the data you're
Exactly.
seeing. How do you like doing this stuff? Is this
I like
fun
it
for
a
you?
lot. It is.
You like
It's
coming
great.
into work this morning? It was like, oh, darn it, I've got to. Was it fun?
No, this
coming
is
in?
an exciting thing to be able to come and do.
Yeah, coming here and doing it.
Yeah, it's really great training.
How'd you get to do this stuff? Is this something you want to do since you were younger? Or,
I did, actually. I wanted to do it probably since I was in junior high. So.
Did you a what?
Since I was in junior high, probably.
In junior high? Okay.
Yeah, so it's been a while.
Did you grow up around here? Or were you
I did. I grew up in Clear Lake, went to Clear Lake High School.
Oh, so my kids go now.
Oh, really?
Yeah, so maybe there's hope.
Maybe.
That's a nice school to go to.
I did.
Isn't it? That's a
Yeah,
nice
yeah, it
way
was
to
great.
go. Okay. All right, Sarah, thanks very much for visiting with us. You got another run coming up here quickly?
Yeah,
or-
a couple more. I think we might have a break, though, first.
Here.
Yeah.
Okay, what's going on? The debriefing with the crew right now?
Yeah.
All right, do you need to pay attention to what's going on?
I didn't have any failures, so I'm probably
All right,
okay.
you're in good shape. All right. Thanks, Sarah. And you're the booster guy.
Correct. So we're looking at the 3 engines. We're looking at data for the external tank,
Yeah.
data for the solid rocket boosters, and data for some of the valves within the orbiter.
Okay.
And some of our data was telling us that the center engine might have failed.
Might have failed.
Might have failed. We couldn't confirm that it was out.
Okay.
And so a lot of the discussion just went on about how we could confirm that it was out if we didn't have some backup cues.
All right.
And we ended up going on an RTLS, or return to launch site trajectory.
Okay. And you should, but that was not the right thing maybe to do?
No,
or
it was the right thing to do. The engine had failed.
It did fail.
Yeah, it took us about a minute to figure out that yes, it was out.
Okay.
And so we had the crew perform the RTLS abort.
Okay. So it all worked out okay.
It did.
All right. What was it like for you? Was it pretty hairy?
It was hairy for the first couple minutes because you couldn't tell if that engine was running, and the flight director is looking for you to tell him yes or no, and you just don't have any data telling you either way.
So what made you decide that it actually was out?
When we got near SRB separation,
Yeah.
the acceleration was about 0.6 Gs, and
When the solid rockets were going to leave.
exactly.
Right.
Normally it's about 0.9 Gs.
Okay.
So our inclination was that it had failed, and
Right.
we told the crew to get ready for the RTLS aboard.
Okay, so that's what it was.
Mm-hmm.
All right, cool. So how do you like doing this? Was it fun for you, or was it?
Oh, it's a blast.
Yeah.
It's stressful. But,
Literally.
yeah.
Yeah. It's stressful, but it's fun.
Exactly. Yeah.
All right. And
You know, they have to make it stressful on us here in the simulations and give us a lot of crazy failures because, when that if one thing does fail on actual launch day, it can be very stressful.
Right. And how long have you been doing this, Rick?
For just over 4 years.
4 years.
And this flight, STS-133, will be my first flight as booster
In the front room.
in the front room.
So you're pretty excited?
Oh yeah. It'll be a lot of fun.
All right. I just said it is a blast.
Yes.
All right, man.